The Kuiper belt is a region outside most of the planets of the solar system. There is a space outside of most of the planets in the solar system called the Kuiper belt. The first object found in the Kuiper belt was Pluto. It took about 60 years to find any more. The first time people saw something from the Kuiper belt was on November 2, 2015. It used to be one of the most interesting pictures ever taken from space, but now that's changed. There has never been a clearer picture of the Kuiper belt than the one that was just taken by the James Webb telescope. There is a cold, donut-shaped area called the Kuiper belt in the outer solar system. It is farther away from the Sun than Neptune, which is the 8th planet from the Sun. It was first interesting because of its shape, but then it became clear that this would be one of the most interesting things about Earth. The Kuiper belt is named for the scientist Gerard Kuiper, whose work in the middle of the 20th century helped us understand the area beyond Pluto, but he wasn't the one who found it. Kuiper wrote a scientific paper in 1951 that made guesses about the possibility of things beyond Pluto. Kuiper's study was mostly about the idea that there might be objects beyond Pluto. It didn't go into specifics about what those objects would be like or how they would be arranged in this area, though at first, Pluto was thought to be the main feature of the Kuiper belt. However, it is now known that Neptune's orbit, not Pluto's, sets the inner edge of the belt. The gravitational pull of Neptune has been very important in shaping how the Kuiper belt moves. Astronomers knew about Kuiper's groundbreaking ideas and contributions, even though his statements did not exactly match up with what was seen in the Kuiper belt. After some time, the idea of the Kuiper belt and the things beyond Pluto that are connected to it became linked to Gerard Kuiper. The first person to find Pluto was the scientist Clyde Tombaugh in 1930. He found it in what is now called the Kuiper belt. At the time of its finding, astronomers didn't know much about the outer solar system and didn't think there would be so many icy worlds beyond Neptune. Most people thought that the solar system was made up of gas giants, hard planets in the middle, and Neptune, an icy giant at the very edge. Scientists at the time thought Pluto was a single planet even though its orbit was irregular and tilted. The second Kuiper belt object wasn't found until 1992, 62 years after the first one. At this point, it was clear that Pluto was not a separate object but rather a member of a larger group of objects in the outer solar system. After that, many KBOS were found, which proved the presence of the Kuiper belt, a region beyond Neptune that is home to a variety of icy worlds. Pluto has a special place in the history of astronomy because it was first called the 9th planet, a name that stuck for many years. However, as we learned more about the Kuiper belt and found more KBOS, especially bigger than Pluto, the International Astronomical Union changed the rules for what makes a body a planet. In 2006, Pluto is now known as a dwarf planet, but it will always be remembered as one of the most important finds in our solar system. Without it, we would not have looked into the Kuiper belt area as much as we do now. This one-of-a-kind place is thought to be an extension of our solar system because it is in the same spot in space and is affected by the Sun's gravity. The 8 major planets plus Neptune make up the inner solar system. The Kuiper belt, on the other hand, goes all the way to the edge of the solar system. The outer solar system is different from the inner solar system. It is made up of icy objects like comets, asteroids, and dwarf planets. NASA says that the stuff in the Kuiper belt is thought to be leftovers from the early solar system, which is about for 6 billion years ago. It is thought to have kept conditions and materials from that time. It's like seeing history happen right now. Pluto and its moons are in this belt, along with Horia, Meghm, and Ares, which are all dwarf planets. Besides that, the Kuiper belt is also home to many different kinds of smaller icy things. This is a unique part of the solar system that we don't see very often. The Kuiper belt is a lot bigger than the main belt of asteroids. The main asteroid belt is made up of mostly asteroids and other rocks that are in the space between Mars and Jupiter. It's not too thick and has a lot of small to medium-sized bodies in it. The Kuiper belt, on the other hand, is a bigger and farther away area. This means that the Kuiper belt has 20 to 100 times more mass than the asteroid belt. This means that the Kuiper belt has a larger amount of matter both in terms of the number of objects and their total weight. That's one reason why it was so surprising that it took so long to find out about this. But the fact that this place wasn't found right away doesn't mean it isn't important to the solar system. A lot of different heavenly bodies live there, such as the small planets Pluto, Haumea, Makemake, and Ares. Pluto was found by Clyde Toomer in 1930. It was once thought to be the 9th planet, but in 2006, the International Astronomical Union changed the standards for planets, which meant Pluto was now called a dwarf planet. With a diameter of about 2,377 kilometers, Pluto circles around the Sun with other large dwarf planets in the Kuiper belt. Researchers and experts have also learned a lot more about this faraway area thanks to their work on Pluto. But this was only the beginning. Horo was found in 2004 by a group led by Mike Brown. Its unique long shape, which may be caused by fast spin, adds to the variety of the Kuiper belt. This dwarf planet, which is about 1,960 kilometers across, has taught us a lot about the interesting things about objects in the Kuiper belt. Makemake is another thing that Mike Brown's team found in 2005. It has its own unique traits. Makemake is about 1,430 kilometers across and doesn't have a big atmosphere. However, its bright surface, which is made up of methane, ethane, and tholin, makes it one of the brightest objects in the Kuiper belt. Ares was also found in 2005. It is a bit smaller than Pluto but heavier, with a diameter of about 2,326 kilometers. Ares is an important part of the Kuiper belt. Its finding led to a re-evaluation of what a planet is and helped us learn more about the variety of objects in the Kuiper belt and how they move together. These dwarf planets tell us a lot about the Kuiper belt's makeup, how it has changed over time, and its place in the past of the solar system. We would have no idea what the area was like without them. A lot of people around the world have mixed up the Kuiper belt and the Oort cloud. What these people don't know is that the Kuiper belt has more objects and is thought to be where short-period comets come from because their orbital periods are shorter. The Oort cloud, on the other hand, is even farther away and shaped like a sphere that covers the whole solar system. It's thought to go from about $2 to 2,000 Australian dollars to maybe $200,000 Australian dollars from the Sun. The Oort cloud is made up of icy objects that look a lot like dirty snowballs. It is thought to be where long-period comets with very elliptical paths that bring them closer to the Sun come from. The Kuiper belt and the Oort cloud are both places and forms that are different from each other, but they are both full of icy bodies. Both are thought to be possible comet sources. Comets are celestial bodies made up of ice dust and volatile compounds. They become noticeable as they get closer to the Sun and get a glowing coma and a tail from the solar wind. It's okay to be confused sometimes, but it's still important to know the difference. Scientists are amazed by this place because the Kuiper belt may only have a small amount of material left over from what it was like in the beginning. What we have now are literally only shards. The real thing has already gone away, not by chance, though. The NICE model is a set of ideas that says that the orbits of the 4 largest planets in the solar system, Jupiter, Saturn, Uranus, and Neptune, might change in a number of important ways. It says that the big planets in the outer solar system haven't always been in the same circular paths. They instead went through a time of dynamic orbital development. The model says that when these big planets interacted with each other, their paths changed in big ways. It was thought that the Kuiper belt held 7 to 10 times the mass of Earth. However, the NICE model says that a lot of that material may have been lost as the orbits of the big planets changed. Material in the Kuiper belt may have been spread out, thrown out of the solar system, or moved to other areas because of the big planets' gravitational pull and changes in their orbits. The Kuiper belt is slowly being worn away because of what's going on. Collisions between objects in the belt can break them up into smaller pieces, which can then collide with other objects in the belt. Different smaller objects might turn into comets at different times. The ones that don't turn into comets get crushed. The solar wind can carry the dust that is made when comets break up to the Sun, where it disappears. The erosion process takes away material from the Kuiper belt over time, which contributes to its slow decline. It is thought that the Kuiper belt holds some of the material that was left over from when the planets in the solar system were formed. Understanding the makeup, dynamics, and history of the belt can give us information about how the solar system formed and evolved. Studying the Kuiper belt can also help us learn more about how planet systems in other stars might be built and change. Astronomers and researchers have a rare chance to look at remnants of our solar system's past. Studying the objects in the Kuiper belt, including dwarf planets, icy worlds, and other celestial bodies, can help us learn more about the solar system and its many parts. Research into the area and the objects within it, like Pluto, Hammer, Makemake, and Ares, can help us better understand the structure and history of our solar system and lead to new ideas about the universe as a whole.